measurement and interpretation of electromagnetic radiations absorbed or emitted from molecule and or atom of a sample from one level or ground level to the higher excited level. In UV spectroscopy, we deal with the UV radiations of 200 to 400 nanometer, in which these radiations interact with the metal and the molecular atom in the sample will move from ground state to the higher energy state. In spectrophotometer it is mainly composed of various parts. First is the light source. Tungsten filament or deuterium lamp is the light source in this, and the tungsten filament is rich in red radiations. Next, when the light is emitted from the light source, then it goes to the monochromator. Usually, we have the meters. When the monochromator passes the lights, it passes to the prism, and the prism then disperses the lights and it gets selected by the slits. Then those beam of lights in the slits are passed into the two reference cells. I will show you. Go to the reference sample. After these beams being passed to the samples, they will then go to the detector. Here, the detector is usually the photo cells. The intensity or the electric current generated in the sample is too low, so we need to amplify it. So we use the amplifier next detector. Amplifier will increase the current generation or electric signal to many folds, so that it can be easily recorded by the computer and those then recorded data can be seen in the form of amplify it. So we use the amplifier next detector. Amplifier will increase the current generation or electric signal to many folds, so that it can be easily recorded by the computer and those then recorded data can be seen in the form of spectra. I will be demonstrating you about the UV vis spectrophotometer. Now I have just initialized the system and the system is initializing. Later on we will system is initializing, then it will ask for the range, like which type of radiations we are going to use, whether UV or vis. I had these samples with me. Now I have one extra test tube having the reference sample, and first I will put the reference sample into the holder that I will put it in the cuvette. This cuvette is made up of quartz. It is not made up of glass because glass can absorb the UV radiation, so we use cuvette made up of quartz. Now this is asking me for the select of source lamp, whether I want visible or UV. Now I will set it on to UV, and now it is asking for the operating mode, single wavelength, multi-scan or time scan. I want single wavelength, so I will press 1. Now it is asking for the wavelength, means up to what extent I want wavelength. I want UV spectra, so I will use maximum wavelength of 400 nanometer. And now I want now it is asking about the measuring mode, whether absorption, so I will use absorption because I want absorption. And now okay, now they had given us a bit of reference that what we want, what had been selected. Now enter. Now they are asking us to put the reference. I will put the reference present in this cuvette into this holder. In this holder we have we have source here, and then we will put it here, and then we have here a detector. Now I will put the reference here. And will then close it and then press enter. Now it will be reading the reference. So now they ask you to put the sample in cell number 1, and I will be placing the sample, my sample, in cell number 1. Now I will be getting out from here. And now we will place it in sample number 1. You see, and then enter. So we have got the absorption spectra at 0.375 nanometer for optical density. This is how UV spectroscopy works. I show you the demonstration in school.